We can now start our hands-on example for the urban scenario for an LTE network planning project. The aim of this exercise is to learn how to set up an urban LTE network analysis project where we will first run a propagation analysis using a ray tracing model, and then as a post-processing step we will run network analysis and inspect results like cell area, data rate, throughput, and observe reference signals like RSRP, RSRQ, and RSSI. The materials provided for this example are as shown on the screen. The first file is the outdoor database that we will use for doing an urban simulation. The second file is the antenna pattern file, which will be used at the transmitter. And the third one is an air interface model of LTE, as you can see on the screen. As the first step, we will first observe the outdoor database that we will use for the simulation. To do that, we first open Wallman and go to File and click on Open Database. Once you click on Open Database, WinProp allows you to select the file that you want to load. We will select city.odb file and click on Open. Once the file is loaded, we see two different views. One is a 2D top view of the entire model, and on the right hand side we see the 3D view of the database. We see buildings of different heights that are placed, as you can see. Any modifications can be made to this database as we have seen on the first session. To continue with our example, we will close the Wall Manager and open Propagation Manager. Once the Propagation Manager opens up, we will click on File and then create a new project. Here we will first select the type of scenario that we are trying to solve. Currently it is set to indoor scenario. From the drop down menu, we will select urban scenarios, vector data for the urban buildings and pixel topo data. Select that. For the 3D building data, click on Select and browse and select city.odb. Once you select the city.odb file, the extension will be shown over here. For the wireless technology menu, we will select network planning based on description file for an air interface. Once you select that, Propagation Manager will ask you to add the air interface model that is provided with this training session. Once that is done, we can click on OK. Select the display height as 1.5 meters and click on OK again. With this, the database will be loaded and we can observe that in the 3D view. We can now save the project by going to File and click on Save Project As and name it as LTE Urban and click on Save. Our next step is to add sites to this database where our transmitters will be added. You can manually define them as we will do in this example. However, For databases or scenarios that can have hundreds of transmitters, the locations of these sites or transmitters can be added on a CSV file and imported in Propagation Manager. This can be done by going to File, Import, and Import Sites. This will make it easier for the user to define hundreds of sites. To manually define a site, there are multiple ways, but there is an option on the left hand side over here on the toolbar to select Add Site. So I will click on Add Site, choose Site with sectors as type of transmitter, and choose a 3-sector site. We are supposed to define 6 sites in total as shown in the instructions. Once we click on OK, we will see the cursor has now changed. You can click on an approximate location for now and then edit the longitude and latitude values. Once I click, a site will be added as you can see on the screen with the site ID, site 1, and 3 different antennas with azimuth values 0, 120, and 240 as you see on the screen. We will individually change the longitude and latitude values for each antenna. We can specify copy or and paste the required values. The height is set at 35 meters. For the carriers, we will select the first one from the list. Click on Assign Carrier and select S2800. Double click on the carrier and set 46 dBm as the output of the PA. Let the transmitted signal to be individual signal setting and then click on OK. Click on OK again and set up the down tilt to 2 degrees. Once we do that, we will now select the antenna pattern by clicking on Select. Once you click on Select, browse to the antenna pattern file and select it. As I click on Select and select the antenna pattern provided, click on Open. You should also see the gain of the antenna over here. We shall repeat this step for all the other antenna. So now I have modified all the 3 antennas with the required parameters. All these 3 antennas are now seen in the Site 1 window. Once you have defined it, you can click on OK. You will see that Site 1 with 3 directional antennas are defined at the required location. In the similar fashion, we will add a Site 2. Let's add Site 2 currently at a random location, and then we can edit the longitude and latitude values. Once again, we see 3 different antennas pointing in 3 different directions. that are automatically added at this site. We will individually go into their properties and define the right set of parameters. So as you can see, I have now defined a site 2 with 3 antennas pointing in 3 different azimuth directions. Following the similar steps, we can now define site 3, 4, 5 and 6. One can also go to Project, Edit Project Parameter tab, go to Sites and set the initial properties of new objects by adding 3 different antennas and adding those properties that remain common to all the sites. Once that is done, we can click on Add over here, which adds a third site, and if I double click the third site, I will see that some default parameters that I require will be already added and I don't have to repeat those steps. Now I will define site 3, 4, 5 and 6 in a similar fashion by just editing the longitude and latitude values for the site and the antennas. Once I change the latitude and longitude values and click on OK, WinProp will ask me if I want to move all the transmitters with the applied change of vector. I will click on No and then click on OK to see that my third site is now defined. Once again, these steps can be repeated by going to Edit Project Parameters, going to Sites tab and click on Add. Once again, we will define the site 4, 5 and 6. So as you can see on the screen, I have defined 6 different sites, each containing 3 different antennas pointing in 3 different directions. These are defined by editing the latitude and longitude values inside each of the site. The next step is to set up the simulation by going to Project and clicking on Edit Project Parameter. A window with several tabs will open up and we will see them one by one. Under the Simulation tab, we can define the prediction plane. We will set the resolution to 10 meters. The height of the prediction plane can be 1.5 meters. We will now move on to the Propagation tab. We can specify the required output directory and request for desired outputs. I will select the line of sight analysis, the channel impulse response, and I will also ask ProMan to write the data about the rays in a .ray file. Please note, if you want to consider a receiving antenna pattern, then you can check this option, click on Edit Parameters, and then define it as a single antenna element or many other options available from the drop-down menu. Or if you have a pattern, you can double click and browse for an antenna pattern. You can add it. At this point, I'm going to click on Cancel as I want the receiving antenna pattern, for example, to set it as omnidirectional pattern. Please note that you can also select the additional output of results in ASCII file to export the results to an external ASCII file. Next, we move on to the Network tab, where output directory for the network results can be specified. I am going with the default ones, but you can click on Change and select a particular folder. We can then specify the desired outputs that could include best server, maximum achievable throughput, minimum required transmitter power, maximum achievable signal strength, reception probability, SNIR, maximum number of parallel stream at pixel, throughput at pixel transmission mode. You can select all these required outputs. I also want to look at the LTE reference signals, that is the RSRP, RSSI and RSRQ. If we go to the air interface tab, we will see the multiple access and the duplex separation, and if MIMO is enabled, we can see all the different available bands. We can also look at all the different available transmission modes, individually see more information about them, edit some information if you want to. Next, we can now go to the computation tab where we will select a right model. We will select the dominant path model, which is recommended for large urban scenarios, which is also based on ray tracing. Only the dominant path or dominant rays will be used. Once we do that, we can click on OK, and the problem setting has been completed. With this, we will go to the computation tab and click on propagation compute all. This will run the propagation analysis for individual antennas. We have 18 transmitters. As you can see, for each and every one of them, WinProp runs dominant path model and calculates the required desired outputs for propagation analysis. So the propagation analysis has now completed. If I want, I can look at the results from individual antennas on each sites. I can look at line of sight analysis and received power. We shall now run the network analysis. We will go to the computation tab and click on network simulation compute all. This should be a fairly quick simulation. It calculates results for each transmission mode. With the network analysis results now available, if I expand the network results and click on cell area, I am now able to see what area is served by which antenna on which site. Similarly, if I also want to look at site area, I can see what region or what area is served by which site. Next, we will look at the reference signals for the LTE. I can expand the section for reference signals on the left. We will look at RSRP. You can also look at RSRQ and RSSI. We can also look at the maximum data rate in downlink, which is 476.2 kilobit per second as the maximum value. We can also look at the max throughput, which is around 23.81 megabits per second to its maximum value. This is how we can perform propagation analysis, look at coverage, and then perform network analysis to look at additional required results. Users can also look at individual transmission mode results. depending on which one is applicable to what region.